In this question, we have to write a program to find all the prime numbers between 0 to 30. So before we start this question, we all have a basic idea about what is prime number. The prime number are those numbers who have only two factors, not more than two or not less than two. Okay, so we run a loop. We run a loop from 0 because we have to find from 0 to till 30, and after that I increases the value. Okay, now we have to run another loop. We have to run another loop where j equals to 1, j less than equal to I, j plus plus. Here you are confusing about why I starts from 0, why j starts from 1, because we have to divide the number 1 from starting 1. Suppose any number, suppose let's number the 7. 7 we have to divide the number 7 from 1. 7 is divisible by 1, yes it is. 7 is divisible by 2, no. 7 is divisible by 3, no. 4, no. 5, no. 6, no. 7, yes. So and 8, no. When the greater number comes, it fails this condition. So we checks less than equal to I. Suppose it is 7, so we have to check 7 numbers, because greater than 7 is not possible, because is 7 divisible by 8? No, it's not possible. So mm, we check if I module j, if I modulus j equal to 0, then we have to count the factor. Okay, we have to count, increasing the count, and we have to make counter variable count equals to 0 in initially. Why we declare this count variable under the first loop? Because not the outer, before outer loop, because if we create a before the outer loop, then it doesn't count. Doesn't count, it counts exactly the total numbers from here, but we have to count all the numbers. So if I divisible by j equal to 0, we count, and after the for loop, after the inner for loop, we have to check the condition. If count equals to 2, then what we have to do, we have to print all the numbers between 0 to 30. Okay, now let's run the code. Yes, 2, 3, 5, 7, 11, 13, all the numbers between 0 to 30, prime numbers are coming here. Why? Let's dry run on this. Okay, in initially the value of I is 0. Okay, is 0 less than 30? Yes, it is less than. Count equals to 0. Okay, now j starts from 1. J starts from 1, and is j less than equal to I? J1, 0 is 1 less than 0? No, it is not. So it goes to there and increase the value of I becomes 1. Now I becomes 1. J starts again from 1. Is j less than equal to 1? Because the value of I is becomes 1. Is j less than equal to 1? Yes, it is less than equal to, because the value of j is also 1. Now it checks, is 1 divisible by 1? Yes, it is divisible by 1. So counter variable increase the count. Now count equals to 1. Okay, now it in now the loop is over, conditional statement is over. It goes to again here. Okay, it increases the value of I, and I becomes 2. I becomes 2. Now it goes to there and check j j is equal to 1. Is j less than equal to 2? Yes, it is less than. Now 2 is divisible by 1. Yes, it is. Then count equals to count increases. Count increases 1 for 2 because the number are 2. The number is 2. 1 का तो खेला ही खत्म हो गया क्योंकि 1 के पास सिर्फ ओनली 1 थे. तो 2 now it starts from in the count is 1. Again the number increases j equals to 2. Is 2 less than equal to I? The value of I becomes 2, right? The value of I becomes 2. Yes, it is less than equal to 2. So it checks this condition and increase the count variable. Now count is 2. Now j equals to 3. Is 3 less than equal to 2? No, it is not. So it doesn't enter any of these conditions. Count is 2. So it prints 2, right? It prints 2. Now the I increases and I becomes 3. Okay, I increases 3. Let's clear this. You understand that dry run, you have to dry run by your own. That then only you understand the questions. This is the code for finding the prime numbers between 0 to 30. Okay, thank you. I hope you understand, and you have to dry run on copy because when you dry run on the pen and paper, you understand very well how the code runs. In starting, the value on is 0, increases 1, 2, 3, 4, and all these values are divisible by j. J becomes also increases 1, 2, 3, 4 till the value of I. Okay, thank you.